students, today we are going to learn an important topic, that is coordination compound. In this session, we are going to learn what do you mean by coordination compound, where do we identify the coordination compound, what are the main points present in the coordination compound, a complete detailed ideas. Come on, let us go and identify that. Coordination compound, it's a complex compound. Generally we say coordination compound, it's a complex compound. Saturated molecules in a different species retains its identity in solid as well as liquid state, that means dissolved in water, and it is made up of ligand, central atom, complex ion, cation, anion complexes, and so on. Yes. Now, where do we identify the coordination compound? In living system as well as non-living system. Yeah, these compounds found in living system and non-living system, hemoglobin in our blood, the hemoglobin is there, no? That is a coordination complex compound only. And chlorophyll, which is present in the leaf plants, that is also complex compound. Vitamin B12, that is also find what it is, complex compound found in living system, and also find in electroplating, textile dyeing, and medicinal chemistry. These are all surrounded by coordination compound. Now come on, let us go and learn line by line what do you mean by ligand, central atom, complex ion. Each and everything will go detailed way. Now we are going to see a complete idea about coordination compound. Coordination compound consists of coordination entity. So what are all present in that coordination entity? Central metal atom or ion, ligand, coordination number, coordination sphere, and counter ion. Okay, central metal ion, the word only says that atom or ion will be present in the center. Okay, so the ligands are surrounded by the central metal atom or ion. That is what it has mentioned. The ligands bound to the central metal atom or ion. Generally, metals are donating electrons, so we can say it is an electropositive. Okay, but here metals are receiving electron, it accepts the electron, accepts a pair of electron. That is what we are mentioning here, Lewis acid. Generally, central metal atom or ion, we can say Lewis acid, because and now choose the correct answer, they will ask such kind of questions. And also please note down, central metal ion is also known as Lewis acid because it accepts a pair of electron from the ligand which is surrounded by the central metal atom. Okay, now the second one, ligand, that is the main. Okay, so ions are molecules bounded to the central metal atom or ion. So this we can say Lewis base. Why? It is ready to donate the pair of electron. That is what it is, a donor atom, and we can say it is a Lewis base. Okay, now next one. Now, coordination number. Number of ligand, that means how many number of donor atoms which is surrounded by the central metal ion or atom. So, that is what it is, coordination number. So, number of ligand donor atoms. Number, we have to mention how many number of ligands are present surrounded by the central metal atom or ion. So, number of ligand donor atoms which the metal ion directly bound. Next one, coordination sphere. So what do you mean by coordination sphere? The bound to that central metal ion and ligand combined together, there will be a square bracket. So that is called what it is, coordination sphere. See, part of the coordination compound containing central metal atom or ion bound directly to the ligand in the square bracket. Okay, then last one, outside the last one, what it is, counter ion, outside the square bracket only, counter ion. See, ion outside the coordination sphere in the square bracket, so that is called what it is, counter ion. I hope you got a clear idea. Central metal ion or atom, ligand, coordination number, coordination sphere, and counter ion. All these combined together, I'll give one example. K4FeCN6, one square bracket. Is it visible to you? K4FeCN6. Okay, now K4 is what it is? K4 it is counter ion outside the square bracket. Fe, central metal ion. Cn, it is a ligand. 6, it is the coordination number. I hope you got a clear idea. Okay, just rub out this so that I'll put it very clearly. K4 FeCN6. Okay, so this is what it is, counter ion. K4, it is a counter ion. Fe, central metal ion. Central metal ion. Okay, now this is Cn, ligand. And 6, coordination number. Coordination number. And this one, the square bracket, no, this is coordination sphere. This is coordination sphere. I hope you got a clear idea. This is K4FeCN6, potassium ferrocyanide. So that is what complete idea they have given. Okay, now we are going to see each and everything in a detailed way. Now we are going to see the classification of ligands. Already you know very well what do you mean by ligand. Ligand which is surrounded by the central metal atom. So that is actually donor atom to the central metal ion or atom. Okay, now how can we identify the ligands? Now here, simple ions such as chloride ion, small molecules such as water, ammonia. So these are all ligands. Okay, now large molecules such as NH2, CH2, CH2, NH2, that is ethylene diamine, CH2, CH2, NH2 thrice N, and macromolecules also such as protein. So these are all accepted as a ligand. Okay, now based on the classification, based on the number of donor atoms. So how many number of donor atoms to the central metal ion? We can say that is mono, di, tri, tetra, poly, like that we can identify. So based on the number of donor atoms, ligands are classified mono, di, tri, tetra, poly, I just mentioned. Okay, now monodentate ligands which coordinate with the central metal ion through only one atom, it is called monodentate. So what are the monodentate ions? Let us go and identify. Now, name of the ligand, formula, donor atom. Okay, now for example, one, ammonia. Ammonia, NH3. So, nitrogen is the donor atom. Then second one, carbonyl. Carbonyl, CO, and oxygen is the donor atom. Third one, hydroxyl. Hydroxyl, which is the donor atom, OH minus, no, oxygen is the donor atom. In that way, we can identify which is a donor atom. Only one atom which is eligible to donate atoms to the central metal ion. So that is what unidentate or monodentate. Suppose two atoms are donating, means it's a bidentate or didentate. And then tri, tetra, poly, like that we can go on tell how many atoms donating a pair of electron to the central atom. According to that, we can name them. Okay, now this is monodentate. Now we are going to see the di, tri, tetra, poly. Next one, nitrosyl. Nitrosyl, NO, donor atom, nitrogen. Next one, halide. Halide, X minus, of course, halogen only is the donor atom. Next one, cyanide. These are all will help you to identify which is whether it is a monodentate or didentate or polydentate, which is the donor atom. Easily you can identify when you are looking at this one. Okay, cyanide is Cn, which is the donor atom. Of course, carbon is the donor atom. Seventh one, acetate. Acetate. CH3, COO minus. Naturally, oxygen is the donor atom. Okay, now we are going to see the bidentate, tridentate, tetradentate and polydentate examples only. So easily we can identify. Now we are going to see the bidentate. Two donor atoms simultaneously coordinate with the central metal ion or atom. Okay, so two donor atoms will be in one compound. In that way we can identify. See, these examples are really will help you to identify the answer from the objective type questions. Okay, come on. Here the first one, ethane diamine. Ethane 1,2 diamine. Okay, now this is the example. Structural formula H2N CH2 CH2 NH2. So which is the donor atom? Nitrogen is the donor atom. How many donor atoms? Of course, 2 is the donor atom because here bidentate. The second one, a dimethyl glyoxime. Okay, dimethyl glyoxime. Oxime compound we have learnt in amino compound, right? Okay, now glycol, glycerol, in that way, glyoxime. Okay, dimethyl CH3 CNOH. Okay, then here CNOH and CH3. So this is the structural formula of dimethyl glyoxide. Now who is the donor? Of course, nitrogen is the donor. Nitrogen is more electronegative than carbon, no? So how many donor atoms here? Here also two. Next one, oxalate ion. Oxalic acid, no, oxalate ion. Okay, now here OOC COO minus. Okay, now which is that donor atom? Oxygen is the donor atom. How many donor atoms? Two. Okay, glycinate, fourth one, glycinate. Okay, NH2 CH2 COO minus. Okay, now here, who are the donor atoms? Nitrogen and oxygen. Okay, so nitrogen and oxygen. So these are the two donor atoms. Hope you got a clear idea about monodentate and didentate. Now, the next one we are going to see tridentate, tetradentate, because those points also it's very important. Now the next one, tridentate. So three donor atoms to the central metal ion. Okay, now I'll give the example. NH, CH2, CH2, NH2. The same way here. CH2, CH2, NH2. Okay, now how many donor atoms? Three donor atoms. Who's the donor? Nitrogen. Three atoms which is donating to the central metal ion. Okay, how to remember? Just a CH2, NH2. Here also CH2, NH2. One hydrogen, removal of one hydrogen. Just you are attaching CH2, NH2 group. The same way we can take this idea only for tetradentate. Four donor atoms simultaneously coordinate with central metal ion or atom. Okay, now this also the same. Just I am bringing here NH2, NH, CH2, CH2, NH2, here CH2, CH2, NH2. Now, I just remove one hydrogen atom, removal of one hydrogen atom. What I am just doing? CH2, CH2, NH2. Okay, you just remember these are all the tricks to identify. No need to by heart, just to understand it. Okay, now how many nitrogen atom is available? 1, 2, 3, and 4. So 4 nitrogen atom is there. Okay, who's the donor? Nitrogen is the donor. Tetradentate. Okay, now hexadentate. Hexadentate. Okay, that means 6 donor atoms. Okay, now come on, let us go and identify who's at 6 donor atoms. Okay, now here, this also the same idea. Ethylene diamine, you remember. Ethylene diamine, what it is? CH2, CH2, here NH2, here NH2. So ethylene diamine. So removal of 2 hydrogen, you just attach 2 molecules of acetic acid. Acetic acid, when you are attaching here CH2 COOH and here CH2 COOH. So you know what is it? Example, the great example, EDTA. Famous name, EDTA, ethylene diamine tetra acetic acid. Here ethylene diamine tetraacetate ion, because ion only is the donor. Okay, I just mentioned here. See, well, writing now you feel you so big example. How do we remember? It's so simple. You just see the trick. Ethylene diamine is the backbone. From that you can bring it. Okay. So here also two hydrogen you just remove. Here in this also. Here CH2 COOH. The same way CH2 COOH. So ethylene diamine. The common name ethylene diamine. Tetraacetic acid. Okay, tetra. One, two, three, four. Acetic acid. Now, who is the donor? How many donor atoms? Already I mentioned six donor atoms. Who are all donor atom? Of course, nitrogen is the donor atom. Next to more electronegativity, oxygen is the donor atom. Now that means acetate ion only. No, this is tetraacetate ion. Generally, ion only, it's the donor. Okay, now that means here so nitrogen and oxygen is the donor. How many donor atoms? Six donor atoms. Hope you remember that formula. How to remember the formula also have given the clue. Hope you understand. Okay, now next one amphidentate. We are going to see amphibian means that frog can live land as well as in water. In that way, any one can donate at a time. See, any one atom can donate at a time to that central metal ion. See, that's what they mentioned. Ligands which contain more than one donor atom. In that, more than one donor atom will be available. But coordinate with the central metal ion or atom using any one of the side at a time. It's called amphidentate. Okay, now here come to this point. Nitro group it is there. Now metal ion which is donating NO2. So nitro group, nitrogen is donating means we can say it's a nitro, or else metal ion which is N double bond O, here oxygen. Oxygen is donating means we can say nitrito. The name which is called nitrito. The same way, cyano group it is there. Cyano group, now metal ion which is donating. Carbon which is donating means we can say it is a cyano. Or else metal group which is donating NC. Nitrogen which is donating. Nitrogen atom it's donating means which is called isocyano. Isocyanate. Okay, now the next one, thiocyanate. This is called thiocyanate. Now the same way here, metal which is donating here SCN. So sulfur can donate. We can say it is a thiocyanate. Thiocyanate. Whereas here NCS. Okay, now nitrogen is donating means we can say isothiocyanate. Isothiocyanate. Okay, so we can identify in that way any one at a time which will donate. So that is called amphidentate. Hope you got a clear idea. Suppose the name they mention isocyanate means who's the donor? Nitrogen is the donor in that cyanide group. Okay, suppose nitro group, oxygen is donor means what is the name of it? Nitrito. Here nitro, and the same way thiocyanate here SCN, S mentioned for thio. Okay, thionyl chloride we remember now. Okay, thiocyanate. In this way sulfur gives means thio group will be there, thiocyanate, whereas N nitrogen it is coming means isothiocyanate. Hope you're clear with this monodentate, bidentate, tridentate, tetradentate and amphidentate, all those ideas. Okay, now the next one, chelating ligand. Chelating ligand, it is a ring formation structure. That's all. Monodentate, didentate, polydentate, like that we have gone through. No, this is a ring formation of the structure. Here also the same. More than one donor atoms will be there. Bidentate or polydentate ligand can attach with the same central metal ion or atom with the two or more donor atoms. Two or more donor atoms forming ring structure. Okay, so that is called chelating ligand. Hope you can remember that. What do you mean by chelating ligand? You remember chelating ligand means it is a ring structure formation. Okay, now they have given the example copper 2 plus ion complex with ethylene diamine. That means ethane 1,2 diamine. That is the main point you please remember for this example. For everything, for this, all those examples, you please remember ethylene 1,2 diamine. Okay, now ethylene 1,2 diamine, just I'll put it like this way. Copper 2 plus, so I'll put it like this. Okay, now here CH2 NH2. The same way here CH2 NH2. Okay, now here NH2 CH2. Here also NH2 CH2. Okay, this both. Now, I hope you got a clear idea about the ring formation structure. So, this CH2, NH2, CH2, NH2, ethylene diamine. Okay, CH2, CH2, here NH2, NH2, here NH2. So this is what ethylene diamine. No, in that copper 2 plus ion complex formation. So that means here copper it's here in this ethylene diamine and this side also ethylene diamine. So ethylene diamine along with the copper 2 plus ion formation takes place. So this is actually what it is, chelating complexes. These are all the examples will help you to identify the objective type questions. Hope you remember all these points. As we are mentioning monodentate, bidentate, tridentate, tetradentate, polydentate, like that, all those dentates we are mentioning, no? So the number of ligating groups, it is called denticity. So that is what the name we have mentioned, mono, di, tri, poly, like that. Okay, so the number of ligating groups, the number of ligating groups, ligating groups, it's called denticity. Okay, so one more question. What do you mean by denticity? They may ask. Okay, so I just mentioned all those things whichever is relevant for you. Okay, denticity, like atomicity, now number of molecules, we can say atomicity like that. Denticity means what it is? The number of ligating groups, which is called denticity. Hope you understand all these ideas. Next class, we will learn some more interesting points.